right, so back on this slide, we figured out the general logic of what we want the motors to be doing. Now we need to figure out how we're going to take these values from the controller that we get, combine them together, and then make two signals, one for the left motor, one for the right motor. So it sounds complicated, but it's not that bad actually. So let's just start by focusing at position 1. We want to set full throttle when it's up all the way. We want to set full throttle to both motors, both positive, both forward, everything the same. So we've got some options for how we combine these mathematically. We can multiply them together, divide them. And remember, division has both ways. So you can divide one and then flip it over and divide the other. So we'll try both of those. Addition and subtraction. So let's start with multiplication. When we push straight up, if we combine x and y by multiplying together, 0 times 4,000 would give us an output of 0, which would mean the motors wouldn't be spinning. So multiplication does not work. And if it doesn't work for position 1, that means we can't use it because it has to work for all positions. I hope that makes sense. So we can just rule out multiplication now. We're not going to be multiplying x and y together to get our number. Well, let's try division next. So if we do 0 divided by 4,000, that is 0. So it doesn't work as well. It doesn't deliver us a full-on value. It would deliver us stop when we went straight forward, and that would be super weird to be stopped. So let's try it the other way though. So 4,000 divided by 0, and that, if you know a little bit about your mathematics, that is undefined, so that can't be done either. So already we've ruled out multiplication and division for all the positions. Like it doesn't work in one, doesn't work in any of them. Next thing, addition and subtraction. Well, what if we were to take the 4,000 and add it to 0? That would work. That would give us 4,000. And we could send that to the left motor and the right motor. Well, what would happen if we subtracted? If we did 4,000 minus 0, we would still get 4,000. The only thing that wouldn't work is if we went 0 minus 4,000, because that would give us a negative 4,000. All right, so we ruled stuff down. We've said, hey, if we add it, it works. And if we subtract it, with y being first, 4,000 minus 0, that works as well. So we've got two possible things to do now. All right, so let's move on to the next position. So in the first position, we've done a lot. We ruled out multiplication, we ruled out division, and we ruled out x minus y. Y minus x still works. 4,000 minus 0 gives us a 4,000, and we've left in adding as well. All right, next position. So in position 2, remember in position 2, we want the left motor to be positive and the right motor to be less than that. So we want the left motor to be faster, the right motor left, and then we didn't care if it was negative or not. All right, so let's play with this. We know only things we have left are adding, which if I add x and y together, I get like 5,600, which is a big fast number, more than our high speed, and that's what I want my left motor to be. All right, so it looks like we might want to go left motor is y plus x. That might work. But then the right motor we want to be slower. So instead of adding them together, what if we just did y minus x? That would give us 2,800 minus 2,800 of 0. And that would make the right motor smaller. Oh, that would work in this position at least, right? So if we add, for the left motor, if we add these two numbers, we get a big fast left motor. If we subtract them, we get and then for the right motor, if we subtract them, we get a smaller number. So this is working as well, okay? The only thing we have to be careful about now is that when we added these two together, we got a number bigger than 4,000. We're going to need to deal with that in the code. We cannot send our motor anything bigger than the 4,094. Otherwise, if you do, the motor will just shut off. So we'll have to figure out how to solve that problem with the code. But right now we have something that's working. It's delivering us big left motor values and small right motor values. Let's look at position 3 real quick. In this one, remember, we wanted them to be the same but opposite signs. So here, if we do, for the left motor would be y plus x. So y is 0 plus x of 4,000. 0 plus 4,000 is 4,000. The right motor would be calculated by doing y minus x. So 0 minus 4,000 the right would be negative 4,000. So that works here too. So the left motor is positive 4,000, right motor is negative 4,000. So yay, we win. Let's check the bottom one real quick. So X is equal to 0 here, Y is equal to negative 4,000. So our left motor, we want them both to be, let's look back, both to be negative. So here we say that 0, or let's say the first one, Y plus X, negative 4,000 plus 0 is negative 4,000. Perfect. And then the other one is Y minus X, and this one is negative 4,000 minus 0, still negative 4,000. Boom, working. All right, we won't walk through the rest of them. I think that's enough for you to kind of see the pattern. You can test the pattern later when we do the code and do it out. But let's try this as our first pattern. Right there. So the left motor is going to be added. The right motor speed is going to be subtracting the two values.